Now let's take a moment and summarize some of the different things that we've been looking at, comparing some of the different tests that we've been using. We're going to use the different tests that we've been looking at, such as the z-test, the single sample t-test, or the two sample independent t-test, depending on different data that we have. Now for the z-test that we started off with, we need to know the population mean, the population standard deviation, and then we just need to have the average of some sample. And then we can use the z-test. Now the problem with this is that you have to know a lot of information about the population, and we usually don't have that. So if we want to compare a single sample to a population mean, we need to use the sample standard deviation rather than the population standard deviation. So that would be the single sample t-test. That was like the Sunday school example that we looked at. And so we would use the formula for the t, or the t-test that comes in Excel. Now the two sample, the independent sample t-test, is where we have two different samples that are completely independent of each other, and we use the average from one t-test or the average from one sample and its standard deviation, and then we use the average from the second sample and its standard deviation, and this big, long, hairy formula that we use to calculate the t-test. So we didn't have to know anything about the population here to see if these two samples were different. So this is just kind of a summary on the different tests that we're using. Now let's talk about confidence intervals. In this example, we have Garfield sitting watching TV, and he's watching the weather. And the weatherman says, "Taking a look at tomorrow's weather, the high temperature will be between 40 below zero and 200 above." And this is Fahrenheit, in case you're watching this someplace else. So that's about 40 below zero is in Fahrenheit, 40 below zero centigrade, and 200 above is about 100 and no, it's about 90 degrees C. Garfield's conclusion is this guy's never wrong. Now, why is this weatherman never wrong? Because he chose such a wide interval to predict the high temperature between 40 and 200. The temperature's always between 40 and 200. And because of that, he can be right. Now, this is similar to the concept of a confidence interval. A confidence interval is a range of values that probably contains the true value. So here, the weatherman gave a huge interval from 400 to 200. Not very useful, but if he had said something like the high tomorrow will be between 75 and 85, that's much more narrow. And here in California, he would have a much greater chance of being right if he had said simply, oh, the high tomorrow is going to be 80. So a confidence interval allows us to be right more often than if we try to guess the exact temperature. So we're going to look at how to calculate confidence intervals when we measure some descriptive statistic. And another concept here are the confidence limits that are the values that bound to the confidence interval. So 40 to 200 was the interval, and the limits were 40 and 200. Now we're going to be especially interested in the 95% confidence interval of the mean if we're trying to figure out the average of something. It's going to be such an interval that the probability is 95% that the interval contains the true population mean. That means it's kind of like, oh, we're going to throw a dart, it's going to land someplace, and we're going to put a target someplace so that we would hit it 95% of the time. So what we're going to do is we're going to try to figure out the confidence interval for how much do students really like Justin Bieber and the Kardashians, or at least how much do students like grad students at Azusa Pacific like Justin Bieber and the Kardashian. And so we're going to use data analysis, descriptive statistics, to get the 95% confidence interval. And we'll do that in the next video. But what the results that we're going to report will look like this. This is the APA format for writing confidence intervals. The CI is the expression for confidence interval, and 95% CI is the standard phrase that we use. We would say the 95% CI for Justin Bieber equals 2.52 plus or minus 0.59, or we can write it with square brackets. We could write 95% CI in square brackets and do the 2.52 minus 0.59, which is this number, all the way through 2.52 plus 0.59, which is this number, and close it off in brackets. And so we can be 95% sure that if we surveyed all the grad students at APU, there's how much they'd like Justin Bieber would be 2.5 plus or minus 0.6 on a scale of 1 to 5 on how much they like Justin Bieber. And the same thing for the Kardashians, it would be 1.52 plus or minus 0.40, so about 1.0 to 1.92. Ooh, quite a bit lower. So we can be 95% sure that this contains the true value and 95% sure that this range contains the same value. And it's interesting, there's no overlap, and this is roughly the same that's saying that the difference is significantly different on what people think of Justin Bieber and the Kardashians.